Welcome to the Workshop Guru.
It all began with a spark of imagination and a crank of iron. The Benz patent motor wagon, the world's first true automobile, born in 1885. A single-cylinder engine, less than 1 horsepower, yet powerful enough to change everything. Carl Benz built more than a machine. He built a dream that moved on its own.
From wooden steel to polished chrome, from hand-turned bolts to artificial intelligence, the journey of luxury began here.
From this fragile frame of steel and brass came a century of progress, design, and luxury. Today, that same spirit drives an entire industry, where craftsmanship meets intelligence. Every curve was tested in the wind, shaped not for vanity, but for silence. Aerodynamics became artistry, where air itself became part of the design. Here, craftsmanship met computation. Before digital 3D modeling ruled the industry, Mercedes sculptors and engineers carved the future by hand, guided by mathematics, refined by instinct.
Beneath the bonnet, a hand-built V12 engine.
But luxury wasn't meant for the showroom. It had to be proven on the road. Each vehicle endured thousands of kilometers through German highways and harsh terrain, where silence was measured in decibels and comfort in millimeters. The suspension was a masterpiece of geometry, an orchestra of steel and hydraulics that absorbed motion before passengers even felt it. On the line, precision robots worked alongside human hands to ensure no vibration went unbalanced. Inside the factory, engineers treated each part like a living organism, dissected, examined, perfected. Nothing was left to chance. Before a single part was built, Mercedes engineers visualized strength in 3 dimensions. Each suspension arm, each joint, was digitally tested, long before metal touched machine. Inside, luxury wasn't left to chance. Designers built full-scale mock-ups, testing every motion of the driver's hands, eyes, and posture, because comfort was measured in milliseconds of reaction time. Every contour was sculpted by hand, guided by patience and purpose. From virtual design to handcrafted precision, Mercedes redefined what a luxury car could be. But to bring perfection from sketches to steel, it was time to transform design into production. During impact tests, the S-Class safety cell absorbed up to 50% more energy than its predecessor. The new airbag system deployed in under 30 milliseconds, faster than the blink of an eye. After every test, engineers documented structural deformation, measured weld integrity, and compared data to computer simulations. Each result fed directly into new CAD revisions. Mercedes built over 100 prototype bodies solely for destructive testing, an unprecedented number at the time. Each test confirmed that precision manufacturing could translate into predictable safety. Under the hood, Mercedes developed its next-generation inline and V-series engines with variable intake geometry. Components such as pistons, rods, and camshafts were redesigned to reduce friction losses by nearly 10%. Before every car left the factory, each wheel assembly underwent dynamic balancing. Sensors measured vibration to within 1/10 of a millimeter. Next came real-world trials. Vehicles were driven for thousands of kilometers on specialized test tracks, often with partially exposed cabins, allowing engineers to monitor airflow, cabin acoustics, and thermal comfort in real time. Interior testing focused on ergonomics. The W140 introduced an advanced seat memory system with 12-way adjustment, automatic steering column movement, and mirror alignment synchronized to driver profiles. Details were engineered with surgical precision. Even the door handles incorporated soft-touch mechanisms to reduce closing effort and wear resistance testing equivalent to 20 years of use. A new pneumatic system powered not only the central locking, but also the self-closing trunk and doors. Inside, the cabin reflected understated authority. Burl walnut wood, integrated SRS airbags, and early multiplex wiring hinted at the digital age to come. Every interior component, down to the glove box, hinges, and dampers, was tested for smooth operation under extreme temperature cycles. Mercedes engineers introduced advanced polyurethane foams for tactile surfaces, balancing durability with comfort. But on the other side of Europe, another idea of perfection was taking shape, one where logic yielded to emotion and precision met passion at 8,000 revolutions per minute. In 1999, Ferrari began a new chapter in structural engineering, the introduction of an all-aluminum space frame, first applied in the 360 Modena. This architecture replaced traditional steel with lightweight alloys designed for strength, rigidity, and balance. The frames are constructed using a combination of aluminum casting and extrusion techniques, each section optimized for load distribution through finite element analysis. Each frame is assembled within a precision jig system. Operators ensure sub-millimeter alignment before the structure is permanently joined. Joining methods include gas-shielded welding, cold metal transfer, and structural bonding, all developed to minimize heat distortion while maximizing structural consistency. Multiple robotic stations perform tasks with exact repeatability. Each joint in the aluminum structure is executed with controlled precision. Riveting robots apply constant force to ensure equal penetration depth across all layers. Hydraulic heads insert self-piercing rivets through 3 sheets of aluminum at once, eliminating the need for pre-drilled holes and preserving structural integrity. Once secured, the joint line undergoes ultrasonic testing to verify bonding uniformity and detect any deviation below micrometer range. The outer panels are then positioned and fused to the space frame. Robots execute movements programmed to a tolerance of 0.15 millimeters. Alongside riveting, structural adhesives are applied automatically. Despite automation, final body assembly requires human precision. Skilled technicians manually fit exterior panels to guarantee perfect alignment. Mechanical fastening combines with adhesive curing, producing a hybrid structure that balances lightness, stiffness, and acoustic comfort. After structural assembly, each body shell undergoes visual and tactile inspection.
Every imperfection, even smaller than a human hair, is identified and marked for correction.
Once verified, the surface is mechanically polished using fine grit orbital tools. Each pass evens out micro-deformations and prepares the metal for treatment adhesion. The aluminum skin reaches a mirror-like finish. This step determines how paint layers will later reflect light and color depth. When the finish is complete, the frame is detached from its assembly jig and transferred to the pre-treatment line. The completed shell, now weighing just over 200 kilograms, is ready for cataphoresis coating, known internally as the row-dip phase. Each completed aluminum body enters Ferrari's row-dip line, a rotational dipping system engineered to guarantee full surface coverage. Mounted on a rotating frame, the body is slowly inverted during the immersion cycle. This motion ensures that every internal cavity is uniformly exposed to the treatment solution. The first stage performs an alkaline degrease, removing all remaining particles and machining oils from the aluminum surface. Subsequent rinsing baths neutralize the pH and prepare the metal for electrodeposition, a process where an electric current bonds the primer directly to the chassis. During immersion, an electric field attracts the charged paint particles toward the grounded aluminum frame. Every surface, seen or unseen, receives a perfectly uniform coating thickness. The row-dip system rotates the structure a full 360 degrees through multiple baths. This rotational movement eliminates trapped air pockets and guarantees deep penetration within the framework. Once the cataphoresis layer is complete, the body enters the curing tunnel. Large rotating brushes sweep away airborne particles before baking begins. In this stage, the shell is heated to 180 degrees Celsius. The electrodeposited primer cross-links to the metal surface, creating a single molecular bond between coating and aluminum. In the paint chamber, robotic arms operate with millimeter accuracy. Each movement is pre-programmed according to the car's geometry, ensuring uniform coverage and zero overspray. Ferrari's signature color begins its life here, applied in ultra-thin layers measured in microns. Every pass adds depth, but never excess weight. Electrostatic attraction guides each pigment particle toward the surface, wrapping the body evenly, even in hidden contours. Once dry, every surface is manually inspected. Human touch remains the final authority. After painting, each component is re-examined by hand. The door panel's curvature, gap tolerance, and reflection lines are compared against digital templates. Ferrari specialists use tactile inspection. Fingertips detect surface irregularities smaller than 20 microns. Only flawless panels continue to the assembly stage. From Maranello's artistry of emotion to Stuttgart's architecture of logic, where Ferrari sculpts performance through passion and human touch, Porsche refines it through precision, automation, and control. The Panamera's journey begins not with design, but with force. Each panel starts as cold sheet steel, waiting for a controlled strike measured in thousands of tons. These enormous dies, carved from solid steel, define every contour of the Panamera's body. Tolerances are measured in fractions of a millimeter. A synchronized line of mechanical giants compresses precision into form. 6 consecutive stages that shape, refine, and finish the body sides. Each press performs a single operation before the next takes over, a choreography of power and timing that turns raw metal into design. From the control console, engineers monitor pressure, temperature, and alignment in real time. Every value is logged, analyzed, and stored for traceability. Robotic arms fitted with suction cups feed the line, transferring each blank into position with millisecond accuracy. The first press gives shape, the foundation of the door and roof structure. The second adds precision, forming openings for the fuel cap and windows. As the sequence continues, each mechanical impact strengthens the sheet's geometry. What began as a flat surface now gained stiffness and character. Porsche's automation relies on vacuum transfer, suction mechanisms that move panels seamlessly between stations without human contact. By the final strike, the body side is complete. A single, flawless panel containing the roof edge, door frames, and rear wing in one continuous piece. Each finished sheet leaves the press line and enters quality control. Only panels that meet microscopic tolerances continue forward, perfection verified by touch and by laser. The Panamera's structure is a complex hybrid of materials. High-strength steel forms the safety cell, aluminum reduces weight, and magnesium adds rigidity where precision matters most. Every cavity, every channel, is engineered for both strength and silence, to absorb vibration, not transmit it. Now, the lower structure is aligned. Automated jigs hold the frame to within a tenth of a millimeter, setting the geometry that defines every Panamera built after it. With the frame complete, robotic systems move in from all sides. They measure, adjust, and position the body for the next operation. Door integration. Each robotic unit is calibrated individually. Laser guidance ensures every mounting point aligns within a tenth of a millimeter, a standard demanded by Porsche engineering. Lightweight aluminum doors are lowered into place by servo-actuated arms. A series of microsensors confirm that hinge tolerances match digital design data exactly. The Panamera's body stands complete, a testament to the power of automation and modern engineering discipline. Once the Panamera framework is finalized, the line transitions to Porsche's flagship, the 911. The same engineering rigor now meets a platform built for speed, balance, and heritage. Production begins at the component level, where each small part is selected, measured, and prepared for assembly. Advanced robotic systems position the structural elements with micron-level accuracy, forming the iconic silhouette that has defined the 911 for generations. The body in white then enters a sequence of coatings and protective treatments, each applied with controlled robotic motion to guarantee long-term durability. Layer by layer, the 911's form emerges, with the body fully prepared.
A Porsche 911 receives over 100 carefully layered paint processes.
The Porsche 911 enters the precision paint line. Robotic applicators lay down each layer with controlled motion, ensuring uniform thickness and a flawless surface finish, while attention shifts to the power plant. The engine begins at the crankshaft station, where technicians assemble and secure the rotating assembly with exact torque and alignment. Each component, bearings, gaskets, housings, and timing elements, is positioned by hand with practiced accuracy, reflecting Porsche's blend of automation and skilled craftsmanship. Piece by piece, the flat six structure takes shape, engineered for durability, balance, and unmistakable performance. This is the heart of the 911 in its earliest form. Parallel to powertrain assembly, emblem molds are prepared, defining the signature Carrera script. Inside the factory, upholstery specialists craft the interior by hand. Leather pieces are sewn, fitted, and formed into seat structures with the same focus on precision and consistency. This blend of mechanical engineering and meticulous craftsmanship shapes every 911 from the inside out. Skilled technicians inspect and shape each piece. The dashboard assembly is built as a complete module, integrating ventilation, electronics, and structural components before being brought to the main line. There, robotic systems assist in positioning major assemblies with millimeter accuracy. Glass installation follows, using calibrated suction frames that align the windshield precisely within the body structure. Finally, technicians begin installing exterior components, such as the headlights, each step bringing the 911 closer to completion through a blend of robotics, precision tooling, and human craftsmanship. In parallel, the completed flat six engines advance through their final checks before being prepared for installation. Overhead, assist systems lift each powertrain module, allowing technicians to access mounting points with accuracy and controlled force. Next, convertible models receive their roof modules, guided into place by robotic frames. Rear panels and bumpers are fitted, integrating lighting, exhaust surrounds. The Porsche 911 rolls off the line, and now we move from performance craftsmanship to the world of bespoke luxury, inside the design studios of Rolls-Royce. Every Rolls-Royce begins long before the first panel is formed. The process starts here, with pure geometry. Designers lay down the initial proportion lines, defining the stance, the shoulder, and the overall surfacing strategy. These early sketches establish the vehicle's character long before
With a roof or without?
clay or metal is touched. As concepts develop, dozens of design iterations are produced. From here, the design moves from paper to clay. A fresh clay buck is rough cut using precision knives, following the same master reference lines established in the drawings. Specialized clay modeling tools then shape the surfaces with micron-level accuracy. Modelers repeatedly refine contours, ensuring continuous curves and clean transitions. Clay is added, removed, and reworked as needed. Every correction is evaluated under controlled lighting to verify symmetry and surface quality. Eventually, the model reaches full definition. The floor becomes covered with the remnants of hundreds of adjustments. This is how a Rolls-Royce takes its first physical form. Once the clay form is validated, technicians prepare the model for the next stage, a full surface wrap. This reflective film simulates painted bodywork, allowing the team to assess highlights, shadow lines, and the vehicle's visual mass under studio lighting. The wrap is tensioned across the clay buck, smoothed along the wheel arches, and trimmed to match every contour. This process exposes even the smallest inconsistency in curvature. Engineers and designers then inspect the model at full scale, analyzing door cut lines, shoulder volumes, and the integration of the iconic Pantheon grille. Only after the design team signs off does development move from clay to metal. Skilled craftsmen begin shaping the first aluminum panels, transferring the studio's precise geometry into structural reality, aligning every curve exactly as designed. Each panel is carefully measured and refined by hand. Small adjustments make a big difference. Every edge must be perfect. Long metal templates help craftsmen confirm the shape is consistent across the entire surface. With the frame ready, the body panels slowly come together, piece by piece. Once a piece is ready, it's fitted onto the structure and checked for alignment. Some curves are created using traditional wooden molds, a method that allows perfect symmetry. And finally, the surface is inspected under guided measuring points, guaranteeing the car's iconic smooth lines. Metal shaping now moves into its refinement phase. Skilled craftsmen work the aluminum surface with specialized hammers and dollies, guiding each curve by hand to achieve an uninterrupted flow line across the body. Every tap is deliberate, subtle corrections that bring the panel closer to its final contour. Once the form is complete, the panel is transferred into the paint preparation area. Here, technicians apply the first coatings using controlled spray patterns, ensuring uniform coverage. After curing, the surface is polished to reveal its deep, mirror-like finish. While bodywork progresses, another team focuses on one of the brand's most intricate disciplines, miniature craftsmanship. In dedicated workshops, specialists work under microscopes, assembling tiny components with exacting care. These artisans handle delicate parts, some no larger than a grain of rice, ensuring every detail matches the design specifications. The same precision is applied to the creation of decorative emblems. Each symbol is shaped, secured, and inspected by hand, preserving the tradition of handcrafted identity. As the system is assembled, the iconic Spirit of Ecstasy is integrated into its housing. With exterior systems verified, the focus shifts to the finished vehicle. Distinctive headlights are shaped with crisp light signatures, giving the car its unmistakable presence on the road. The rear lamps follow a similar design discipline, forming a continuous line of illumination that blends seamlessly into the bodywork. Moving to the front, the Spirit of Ecstasy crowns the hood, completing the visual identity that has defined the brand for over a century. The body surfaces reveal their final form, smooth, uninterrupted lines flowing from the shoulder to the tail, crafted for elegance rather than aggression. Bespoke features such as the curated hospitality suite are integrated into the vehicle. With this final inspection complete, the Rolls-Royce stands finished, where engineering, precision, and handcrafted artistry meet in perfection. After witnessing how every detail is designed, now imagine becoming its owner. As your first moments with the Rolls-Royce Spectre begin, the protective films lift away, revealing chrome polished to a mirror. Piece by piece, the body lines emerge, shaped from over 700 aluminum extrusions forming the stiffest Rolls-Royce. Spectre is the brand's first fully electric ultra-luxury coupe. 578 horsepower, 900 Newton-meters of instant torque, and a driving silence so pure it feels designed rather than natural. It glides from 0 to 100 in just over 4 seconds. Effortless, not aggressive, exactly as Rolls-Royce intended. Only a few thousand Spectres are built each year, each one assembled in Goodwood almost entirely by hand. The price begins around $400,000, but each owner writes their own number through bespoke colors, materials, and finishes that no other car will ever share. Now the experience moves inside. Every seal you lift, every protective layer you peel away reveals untouched perfection. Hand-finished panels, deep leather that's never felt the outside air, and an illuminated fascia hiding over 5,000 glowing stars. This isn't simply unboxing a vehicle. It's the private ceremony of welcoming a Rolls-Royce into your life, a ritual only the owner ever feels. And after unwrapping the quiet perfection of a Rolls-Royce, we step behind the scenes of another world of engineering discipline. Bentley. Frames move down the line like unfinished sculptures, shaped, pressed, and measured under strict tolerances. Panels are aligned not by robots alone, but by craftsmen who've spent decades perfecting the curve of a Bentley fender. In inspection tunnels awash with white light, every contour is examined for absolute symmetry. Slowly, the raw shell becomes a body, rigid, flawless, and ready for paint. This is the birthplace of a Bentley, where British craftsmanship and mechanical discipline fuse to form the first heartbeat of a luxury machine. The body tilts and moves through the line, entering the electro-coat tunnel, where an electric charge pulls primer into every microscopic gap. From darkness, it emerges fully sealed and protected. Then the shell rises toward the paint bays. Color finally appears, from deep bronze to vivid red to jet black, each body moving forward like a finished sculpture awaiting its soul. With the painted bodies moving down the main line, Bentley's mechanical heart begins its own journey. Every engine starts as a set of machined blocks and bearing journals. The connecting rods, pistons, and bearings are staged in numbered racks, so nothing is ever left to chance. Inside the assembly hall, cylinders are lubricated and prepared. Pistons slide into place with controlled pressure. As the block grows, technicians guide it through lifts and fixtures, marrying precision parts into a single structure. Cams, springs, valves, sealing surfaces, every interface is checked and confirmed. Piece by piece, the engine becomes whole. Now the engine enters its final stages of assembly. Technicians secure the lower housings, torque every bolt, and verify each channel that feeds oil, coolant, and pressure through the block.
Bentley hand tests every engine for over an hour, checking precision down to 1,000th of a millimeter.
Covers slide into place. Then the engine is moved toward the test chamber. Here, before it ever fires a spark, every system is evaluated: compression, timing, oil flow, vacuum, and sealing. The machine accelerates through simulated loads, revealing any imbalance long before it reaches a car. With the engine tested and certified, it's lifted into position for the marriage stage, where the powertrain meets the body for the first time. Suspension arms and massive chrome wheels follow, each torqued to exact factory values. Panel by panel, the rear body sections close in. Doors are adjusted. Finally, the craftsmen lower the rear glass. Sealed, pressed, and set with absolute care, the Bentley rolls out under its own power, ready to deliver effortless performance on the open road. From the handcrafted elegance of the Bentley Flying Spur, we now shift to a very different expression of luxury engineering, the commanding presence of Russia's Aurus. In Yelabuga, deep within Tatarstan's industrial heart, precision takes a new form. Here, the Aurus begins, not by hand, but by algorithm. Robots move in absolute synchronization, welding a chassis designed to endure not decades, but generations. The final product emerges: massive wheels, thick chrome accents, a squared-off silhouette inspired by Zeal limousines of the Soviet era. Aurus does not hide what it is: a luxury tank shaped into a limousine. Inside BMW's ultra-automated body shop,
From the factories of the past to the fully synchronized production lines of today, this is the new phase of luxury manufacturing.
every movement is pre-programmed to avoid deviations during spot welding. Technicians calibrate the steering and driver interface systems by hand, ensuring both tactile accuracy and software integrity. Interior modules are seated and torqued with controlled force, while robotic systems secure structural fasteners that cannot fail. Now, the finished body lowers onto its completed drivetrain, merging electronics, mechanics, and chassis into a single operating platform. The car undergoes its final functional checks: brake response, sensor communication, lighting, and system diagnostics. And when the final verification completes, the i7 rolls forward silently, powered not only by electricity, but by generations of industrial progress. It's not just how cars are made, it's how the entire industry has evolved.